Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Acetals are hydrolyzed under aqueous acid, H3O+, conditions to regenerate the parent carbonyl compound and the diol, glycol. Each 1,3-dioxylane acetal upon hydrolysis releases one equivalent of ethylene glycol, hot to CH2O, and regenerates the ketone carbonyl at that carbon. Moving on to the next step. Left acetyl carbon, part of a 1,3-dioxylane ring, bears an ethyl group CH2CH3 and a CH2 group connecting to the right acetyl carbon. Upon hydrolysis, this becomes a ketone. The carbon bonded to ethyl and CH2 becomes C is equal to O, giving an ethyl ketone fragment CH3CH2C is equal to O, CH2. Right acetyl carbon, part of a 1,3-dioxylane ring, bears a methyl group CH3 and the CH2 bridge. Upon hydrolysis, this becomes a ketone. The carbon bonded to methyl and CH2 becomes C is equal to O, giving a methyl ketone fragment CH2C is equal to O, CH3. Moving on to the next step. Combining both fragments through the CH2 bridge. CH3CH2C is equal to O, CH2C is equal to O, CH3. This is a 1,3-diketone, hexane, 2,4-dione with an ethyl on one end. Specifically, ethyl group on left carbonyl carbon and methyl on right carbonyl carbon connected by one CH2. The structure is CH3CH2C is equal to O, CH2C is equal to O, CH3, 3-methylpentane, 2,4-dione or pentane, 2,4-dione with ethyl. Actually, this is hexane, 3,5-dione, CH3CH2 co-CH2 co-CH3. And for the final step, A, CH3CH2C is equal to O, CH2C is equal to O, CH2CH3. Both sides have ethyl groups. Incorrect. Right side should be methyl. B, CH3CH2C is equal to O, CH2CH2C is equal to O, CH3 has two CH2 groups between carbonyls. Incorrect. Bridge is only one CH2. C, CH3CH2C is equal to O, CH2C is equal to O, CH3. Left carbonyl has ethyl, right carbonyl has methyl, one CH2 bridge. This matches perfectly. D, CH3C is equal to O, CH2C is equal to O, CH3. Both sides methyl, no ethyl. Incorrect. Option A has two ethyl groups. The right acetyl bore only a methyl. Option B has a CH2CH2 bridge. The structure shows a single CH2 between the two acetyl carbons. Option D has methyl groups on both sides, ignoring the ethyl substituent. Therefore, the correct answer is C. Therefore, the correct answer is option C.